Yeah, thanks. So yeah, welcome all to the live session for week 5 of the course Digital Circuits, which is taught by Professor Shantanu Chattopadhyay, and I am Anant Singhal, a PhD student from IIT Jodhpur. And again, I'll be assisting in solving similar assignment problems that have been given to you in the week 5 assignments. That is more or less related to arithmetic circuits. So let's go to the course outline. So in the previous weeks, we have already covered the basic part of the course, like the gates, different types of gates, the combinational minimization. So we have now good understanding of K maps, then all the different types of gates that we have. So we'll be now dealing with some of the circuits that are there in the course outline. So some of them are multiplexers, demultiplexers, encoders, decoders, etc. So it is like a combined topic for week 5 and 6. So we might be covering some of the week 6 topic here. So maybe yeah, let's we can start with like very simple problems. So I think I don't have very simple problems initially. So yeah, let's see. Hmm. So let's start with a okay, let me start with a very basic explanation of multiplexer. So can anyone tell what is a multiplexer? I think the course has already been covered for that. So it is like a many to one circuit. People also call it as many to one. That means it has many inputs or multiple inputs, you can say, and it has a single output and it has some select lines. So yeah, so what basically multiplexer do is we always have some option of the selecting. So based upon the select lines, either of the input, let's say this is I1, this is I2, this is I3, this is I4. So for example, the output of this multiplexer will be dependent upon these select lines. So let's say if this select line is choosing this particular input, so then this will be the output. Similarly, if this select line is using this particular input as a choice, then this will be the output. So if I try to make like a truth table out of it, so we can have four choices of select lines. Is there any doubt based upon yeah. Oh, no. So as I said, based upon the select lines, the inputs can be I1, I2, I3, I4. And now we have such so understanding that we can even write the final expression that we can write this as S1 S0 I1 plus S1 S0 I2 plus S1 S0 I3 plus S1 S0 I4. So this is the basic, I mean, version of that. We already have that understanding now. And similarly, so what we have is we have multiplexers which have 2 raised power n inputs. It has n select lines. So let me write that. It has 2 raised power n inputs, n select lines, and it has one output. So similarly, we also have a circuit called as demultiplexer, which is exactly the opposite of it. So what is basically a demultiplexer? It is single input and multiple outputs. Similarly, it also has select lines. So let me write that directly. So it again has 2 raised power n outputs and it has a single input. So if I say again the same select lines, so let's make a case of 2. So now what it has is it has 4 outputs. Let's say they are y1, y2, y3, y4. So let's say the input is I. So if it is 0, 0, then this will be 0 and others are getting 0. So it works like that. Based upon the select line, the output will be equals to the input whenever the select line is getting to that corresponding input. I think that you all already might be knowing this. These are all basics. So I just started with just to give you the idea. So let's start with some question. So let's say my first problem is
सर हेलो
yes, yes,
सर वो एक इनपुट और चार वो आउटपुट जो दिए वो सब
yes,
थोड़ा बता दीजिए।
yeah, yeah. So as I said, are you asking about demultiplexer?
जी
Okay. So like, can you please mute yourself back? So So as multiplexer, demultiplexer is completely opposite of that.
जी सर.
I Yeah, please mute. Yeah, fine. So what I'm saying is now, as in the multiplexer, we were having the choice like every select line corresponds to a particular input. Let's say it is 0 0, then this input will be connected to the output. I mean, this will be the final output. Like let's say I1. As I said, if select line is 0 0, then the input is I1. That is what we have written in the expression form also. Similarly, what I'm trying to say for a demultiplexer, now it has 2 raised per n outputs and it has n select lines again. So let's say now it is again 0 0. So what 0 0 is corresponding to this particular output now. So this particular output will become the input like this. So for 0 1, similarly, this particular input will be coming out from here. Oh, sorry. Similarly, if I let's say choose 1 0, then this particular input will be coming as output here and the rest will be 0, which I have marked here and something like that. So it goes on and on. So let's say it has 3 select lines, so it will be having 8 outputs. So that each of the combination should be giving us output at certain, uh, sorry, input at certain output. Is it clear?
ये सर 0 0 सर ये जो S10 और S00 तो Y1I और Y2 Y3 Y4 00 क्यों हुआ?
Because this select line, sorry, because this select line, let's say 0 0 is corresponding to connect this input with this output. So this I will be converted here and rest are grounded, like they are not connected to anything. So they are
ओ,
zero.
अच्छा, ओके 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 सर, ओके
Yeah.
ओके.
Yeah. So maybe you can do a simple problem. So let's say if I ask you number of select lines required for 1 cross n demultiplexer. So demultiplexer is how many? So the first option, let's say n, the second is log n, the third is log to the base 2n, and the fourth is 2 raised per n. Yeah, please take maybe 1 or 2 minutes and type your answers in the chat box. This is quite easy, so don't take much time. Please, I would say to read the question carefully. It says 1 cross n demux. In general, the things that I've told you, it has 1 cross 2 raised per n demux, something like that. As I told you that it has 2 raised per n outputs. Now those outputs are converted to n outputs. So please give answer accordingly. We have got some answers. So yeah, it will be log to the base n. Why? Because as I told you, so let's say again I'll give that example. So let's say we have 4 outputs. So we know that we have 2 select lines, right? So what I'm saying, we have, if we have n outputs now, which is 4, we have 2 select lines. So what I can say is select line, select line, it's, let's say it's m, for example, it's nothing but log to the base 2n, where n is the number of outputs. So for example, if I put n as 4 here, so m will be log to the base 2 4, and this is nothing but 2, which is actually correct. That is, it has 2 select lines. So option third is the correct answer. Let's move ahead. So let's say this is the next problem. It says find canonical POS expression. Let's say the function is A, B, C, something like that. And we have a 4 cross 1 mux, which is having B, C as select lines. And let's say this is A, the knot of this is the second input, the third input it's let's say 1, the fourth input it's let's say 0. So A, B, C. So you need to find the canonical POS form of the expression. So let me give you the options also. So it can be 1, 2, 4, 6. Second can be pi of 0, 3, 5, 7. Third is, sorry, pi of, just happening, 1, 3, 5, 6. Is the question clear to everyone? So this is MUX. MUX means a multiplex. So maybe again you can take 2 minutes and let me know the answers in the chat box. So what one answer is B. So let's try it out. So if you understand the basics, this is very easy actually. So let's try to put it in a table. So it says when BC. So I hope you understand now that this is 0, 1, 2, 3. I mean the inputs when these are 0, 0, then the input, let's say I'm writing the final function. So it will be A. When it is 0, 1, it will be A complement. When it is 1, 0, it will be 1. And when both are 1, it is 0. This table is clear to everyone. I mean, this is quite basic, but yeah, is it clear? Okay. So can I write? So this is nothing but A times what is happening. So it is nothing but A times B bar C bar, right? The first term. The second term is A complement B bar C. The third term is 1. So we need to write both A plus A bar. And this is B C complement. And the fourth term is 0. Is this clear to everyone? The function that I have written just now? Yeah, great. So I can write this as, so this is 1, 0, 0. So it is basically if I write in SOP form, so this is nothing but 1, 0, 0, which is 4. And this is 0, 0, 1, which is 1. Then we have 1, 1, 0. That means 1, 1, 0 is 6. And last we have 0, 1, 0, that is 2. But now we have to make sure that the question is asking the canonical POS form, that is the pi form. So how can we do
Sir,
that? Yes,
sir, why didn't we take plus DC 0, sir? Last row, sir.
because it is, I mean, it is something like 0 multiplied by BC, and this is 0. Like for 1, we have taken a plus a bar. I mean, we could have written like b c bar. So to make it a standard canonical form, what we do is we add a plus a complement, right? So this is what I've done. Similarly, for BC, it would have been multiplied by 0. So it is actually not there. So I mean, this whole term is actually 0.
Sir, 0 means we have neglected it like that, sir.
No, no, it is 0, na? The digital output is 0. So we have multiplied it with 0. Like if you multiply any expression, let's say 0 multiplied by any expression, what will it give? It will give 0, right?
0, yes, sir.
Yeah, so that is why we did not, I mean, I did not write it, but yeah, it is 0 actually, so we cannot, we should not write it.
Yes, sir. Thank
Yeah.
you, sir.
So as the question asked the POS form, so all the remaining bits, that is 0, 1, 2 is there, 3, 4 is there, 5, 6 is there, 7. So this will be the canonical POS form, which is option 2. So option 2 is the right answer. Okay, let's do a better problem now. Okay, so let's say again I've given you, let's say, a 4 cross 1 multiplexer, and I'm saying the output of that multiplexer is x, y plus z. Here x is MSB, sorry, and y is LSB. Sorry, not y but z. And what I can say is, let's say we have chosen x and y as select lines and z as input variable. So you need to find what will be the value of the all the 4 inputs. So let me try to make that. So let's say this is D0, D1, D2, D3. As I said, the select lines are X and Y. Output is this. So this is nothing but 4 cross 1 DMUX. Oh, sorry, MUX. So you need to find D0, D1, D2, D3. So your options are like I'm writing in order. So Z, Z, Z1. Second is Z111. Third is 1Z, Z, Z. Fourth is 1, 1. Yeah. Is the question clear to everyone? Basically, this is Q. Please take a guess. I mean, try it out in your notebooks and let me know. You can take 2-3 minutes. This is a easy problem only. I'll wait for some more answers. Why was it decreasing every week? Yeah, I also don't know that. I always encourage everyone to join classes every week, but yeah, it's not my loss, it's your loss. I'll again encourage everyone to attend all the classes because the topics will get, I mean, much more complex. Starting from next week, we'll have sequential circuits that also involves clocks and all of those things. So those are complex topics. So it would be great if you can attend those lectures regularly. Should we- Okay. Okay, so let's try out some of I've got answers. Yeah, so there is no Z complement terms in the option. So let's see how we can do that. So as I said here, here Q is nothing but sorry x y plus z. So let's write that in the standard form as we in general do. So x y we can write z plus z bar plus we can write x plus x bar y plus y bar times z, which will give me x y z x y z complement x y z plus x y bar z plus x bar y z plus x bar y bar z, which is nothing but summation of, so we have 0 0 1, that is 1, then we have 0 1 1, which is 3, and we have 1 0 1, which is 5, and we have 1 1 0, which is 6, and these two are common 7. So this is what actually Q is, right? So now what we can do is, the method to do that is, step 2 is draw a table or draw like a K map between input and select lines. So let's do that. So as we said that x and y are the x bar y bar x bar y x y x y. Okay, let's do that like that only, not a K map, but let's do as general. So this is nothing but D naught, this is D1, this is D2, this is D3, Z bar and Z. So I now we know that in binary this is 0, this is 1, 2, 3, 4, 5, 6, 7. So now, as I said that in the canonical form, what we have found is we have found 1, 3, 5, 6, 7. Sorry. So can I say that D naught will be nothing but Z? D1 will be Z again, D2 will be Z again, and this will be Z plus Z bar, that is basically 1. Is this clear to everyone?
Sir,
Yes, sir.
is that like Carnot math, sir?
No, it's not a Karnaugh map, it's just a general indication, I mean, of these terms. So I wanted to see that what do I need to multiply to actually get the final answer, because my output or my input expression, let's say, had x bar y bar z. So I've written x bar y bar and then z, and here it is 1. And there is no x bar y bar z bar, so I just need to multiply the input by z, not by 1. So that is why I made a general representation, and wherever we wanted to multiply whatever uh, variable, we have done that. Is it clear to everyone?
Yes, sir.
Okay, let's move ahead then. Okay, let's try out this also. Okay, let's say we have, can we directly put an equation? Okay. So D1, so it actually it is a 4 input. So we do not have 2 input mux, so we cannot write D naught as 0 0 and D1 as 0 1. Okay, let me explain again what I'm trying to do. So here we have just seen that, maybe I'll make one more page. So we have just seen, I mean, few minutes back that the final output will be something like x bar y bar d naught plus x bar y d1 plus x y bar d2 plus x y d3. Is this clear to everyone? Those whosoever is asking to explain again, is it clear? Yeah, so if it is clear, then the final expression actually is x bar y bar z plus x bar y z plus x y bar z plus, sorry, x y z plus z bar. Can you see now what I have done? Why I have written d naught as z, d1 as z, d3, d2 as z, and d3 as 1. Oh, great. So this is what the table did. So all these z's were covered here and the 1 was covered here. X y equals 0 0. There's something someone has written. D naught is not xy plus z. Q is xy plus z. Oh yeah, yeah. I understand what you're trying to say. So yeah, we have done it like that only, but we have written the expression. Okay, let's move to the next problem quickly. So let's do maybe, sorry, some problem with my pen. Yeah. So let's say we have a 8 cross 1 mux. Let me make it 8 cross 1 mux will have 3 select lines, right? Let's say those are A, B, C, 4, 5, 6, 7, 8, and it has a single output. So it is 8 cross 1 mux. So let's say the outputs, sorry, the inputs are 0, D, 0, sorry, 0, D, 0, 0, 1, 0. So this is the 8 cross 1 mux. The output is 0, oh sorry, Y, which is function of ABCD basically. So you need to find the standard canonical SOP form. Let me quickly give the options. This is again straightforward, so don't overthink, just try to do that. Sorry, it's happening. So this is 2, 6, 10, 11, 3, something is wrong. 3, 7, 12, 13. So we have 0, 2, 4, 5, 6, 8, 9, 10, 11, 0, 1, 3, 7, 9. Oh, inputs are okay. Yeah, let me. So the ones that are written in red are D. The rest of them are 0.
ఉన్నారా సార్? హలో.
Yes, who's this? Any answer, anyone? SOP. Okay, so let's try to solve it now. So since now what do we have? We have three select terms. So what is this? This is A bar, B bar, C bar, right? This is A bar, B bar, C. This is 0, 1, 0. This is 1, 0, 0. This is 1, 0. What is wrong with my pen? So this is 5, 6, 5, 1, 0, 1, 1, 1, 0. Whatever this is, ABC. So I can write my final expression as uh, so I have D at A bar, B bar, C. I have a D. Then I have a D at A, B bar, C bar. Then I have a 1 at A, B, C bar. So that basically means A bar, B bar, C, D plus A is happening. Plus A, B bar, C bar, D plus A, B, C bar. Okay, there's something wrong right here. A, B, C bar, D plus A, B, C bar, D bar. So which is nothing but summation. So this is 0, 0, 1, 1, which is 3. This is 1, 0, 0, 1, which is 1, 0, 0, 1 is. Did I write everything correctly? 1, 0, 0 is 4. 0, 1, 2, 3. Sorry. 3 is 0, 1, 1. I not written this correctly. This is wrong. Sorry for the glitch. So it's 0, 1, 1. So this is 1, 0, 0, 0. That means it is 8, I think. Oh, this is 0, 1, 1, 1, which is 7. Then we have 1, 1, 0, 1, which is 13. And we have 1, 1, 0, 0, which is 12. Is it clear to everyone? Hmm. Is there any option like that? Yeah, option second is the correct answer. So okay, let's go to the next problem now. So it says it is a 3 cross 8 decoder to use to implement the function this. What is the midterm? So please let me know the answers. Maybe you can take 2-3 minutes and let me know the answers in the chat box. So just one clarity here, this bubble indicates not gate. So basically the output, or sorry, the input to this thing is y naught bar, not y naught.
Sir, decode also demuxer called.
Yeah, so decoder has only one difference. Instead of having one input, it has 2 raised power n input output. So let's say it has n inputs, so it has 2 raised power n outputs. In DMAX, what do we have? We have 1 cross 2 raised power n. Similarly, encoders, it has 2 raised power n cross 1, but in encoder, sorry, this is MUX, and in encoder, we have 2 raised power n cross n. So this is the only difference that we have. Okay, so I've got some answers. I think someone did option A. Okay, let's see. So the final function that we can see is it's y naught bar, sorry, it's multiplied. What is happening with my pen? Y naught, y1, y2, y3 whole bar. So basically the function will be nothing but y naught plus y1 plus y2 plus y3, right? And function is nothing, so y naught is 0. So I can write this as 0, 1, 2. Oh, sorry, it's not 0, 2, 3, 7 actually. 2, 3, 7. 2, 3, 7. Is it clear to everyone? Those who are saying A, actually it's B. So I mean opposite of that. So I hope it is clear. Everyone was saying A. I don't know why. Is it clear now?
Sir,
Yes.
sir, if time permits, if you please explain encoder decoder fastly, sir. Like overview of.
Okay, okay, fine. Yeah, let me do that. No problem. So let me give you a decoder overview that will be easier for you. I mean, let's maybe do a 2 cross 4. So decoder encoder does not have any select line, so it has, let's say, n inputs and 2 raised per n outputs. So it's n 2 raised per n decoder. So basically what it does is, let's say this is a b. So here what we'll have is we have 0. That means we have a bar b bar. Here we have 0, or here we have 1, right? So here we'll have 0 1. Here we have 1 0, and here we have AB, that is 1. Is it clear? I mean, this is a very basic circuit. It does not use any select lines. It just depends upon whatever the input is. So that is why we make like different kinds of circuit. As you see here, we have added different outputs of the decoder to have a final function. Otherwise, it will have multiple outputs, right? Similarly, it goes for encoder because it is just opposite of that. So encoder may this will be the input and this will be the output. Again, we have some similar problems. Please let me know the answers quickly. This is again a easy problem. Decimal to BCD. Okay, we'll see maybe one problem on that. This should not take much time. Okay, let me quickly tell the decimal to BCD. So decimal to BCD is actually very simple. So in decimal, we know that we have the values from 0 to 9. 4, 5, 6, 7, 8, 9. So the BCD is the actual equivalent of 4-bit of that. So it's 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1. For example, let's say we have 25 to the base 10 in decimal and we want it to be the BCD. So the BCD of this will be 2, that is 0, 0, 1, 0. 5 is 0, 1, 0, 1. 0, 0, 1, 0, 0, 1, 0. Yeah, so this is the BCD. Sorry for the bad writing. Something is wrong with my pen. Is it clear? Whosoever was asking decimal to BCD, it is very.
Sir, could you please explain it again?
Okay, so what I'm trying to say, whatever the decimal number is, you just need to convert it to its corresponding 4-bit equivalent. For example, let's say 12. So in 1, you can write 0001 in binary, right? 4-bit. And 2, you can write 0010. So the final answer would be 0001 0010. Sorry. Is it clear, Mikala? Shekhar? Okay, so let's. What do you mean by binary weight? Let's do this quickly till then. So it is nothing but so y will be first is a bar b bar c plus a bar b c bar and it's a b bar c and c bar. So I am writing both. It's a b bar c bar. So it's nothing but summation 001 is 1. What else do I have? 0 1 0 it's 2. 1 0 1 is 5. 01100 is 4. So option B is the correct answer. How's the design flow course? I'm not aware about it. Uh, no, I'm not the mentor of that. Yeah, RTL to GDS is actually a very good course for those who are aspiring for VLSI jobs. So that is what they basically ask in the interviews. So RTL to GDS is a good course. I think it is taken by Professor Sneh Saurabh, if I'm not wrong. Well, let's do the next problem quickly. So the question is basically design a 4-bit odd parity generator. Is on. Sorry for this. I don't know what is wrong with the pen. And you have to do it using a 4x1 mux. Let's say AB is the select line. So you need to find all the 4 inputs. Your options I can give in form of C and D. Let's say your first option is C XOR D, comma C XOR D. C XOR D, C X not D. The second is I'm writing plus and dot, plus dot 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 plus dot dot plus. Plus means XOR and dot means XNOR. I hope you already know that. So these are your 4 options. So again, you have to do it using a 4x1 mux, where A and B are your select lines. You have 4 inputs which are I0, I1,
Sir,
I2. Yes.
here in question, are you, sir, you are asking like how to use mux slash like art parity generator, sir?
Yeah, you need to design a mux so that whatever input you give, let's say you give these 4 inputs here, so the output will be act like a odd parity generator.
Okay, sir.
Once again, explain, sir.
Okay, let's do that. So it says you have to make a 4-bit parity generator. So that means you need to have 4 inputs. So now there can be total 16 cases. So what will be the output of the odd parity generator? Can anyone tell when the number of, let's say, uh, there are even number of ones, let's say, what is the output of odd parity generator? I told that in the last class. So odd,
0.
so it works in opposite way, right? In input, let's say we have, let's say we have even number of ones, then it is 1 actually, and if we have odd ones, then it is 0. Why? Because let's say this input does not have even number of it has 0 ones basically. So if this bit is 1, then the overall output has odd number of ones. Hence, whenever the input has even number of ones, then the output is 1, and when the input is 0 odd number of ones, then the output is 0. This is what I told in the last class also. So I'll write now the output quickly. So this is 0, this is 0, this is 1, this is 0 1 1 0. So it already has, so this is 0 1 0 0 1 0 1. I hope the output is already clear to everyone. So what we can do now, we can make the K map, right? We need to solve for C and D. So here A, B are the select lines. So let me write like that only. A bar, B bar, A bar, B. It's wrong. A, B bar. Sorry, this is a K map. So A, B will come first. Similarly, this will C bar, D bar, C bar, D, C, D, and C, D bar. This is 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. So here the 1 is at 0, so now here 1, then 0 1 2 3 4 5 6, 5 is here, 6 is here, and we have at 9 10, and then we have at 12 and 15. Is it clear to everyone? Okay. So now what we need to do is, so we already know that this I naught is A bar B bar times something, right? So this is basically I naught, this is I1, this is I2, this is I3. So basically this column is I naught, this column is I1, this column is I2, and this column is I3. So we just need to write the final expressions, that will be your answer. So let me write that. So I naught is C bar D bar plus CD. I1 is C bar D plus CD bar. I2 is C bar D bar plus CD. I3 is C bar D plus CD bar. So which is nothing but, can anyone tell what is this? This is C. This is C XNOR D, right? I hope you already know that. This is XOR, this is XOR, and this is XNOR. Oh, sorry. This is XNOR, and this is XOR. Is it clear to everyone?
Yes, sir.
Okay, so the answer, I think, what is the answer? XNOR, XOR, XNOR, XOR. Sorry, I think there is no option like that. So yeah, I mean, this will be the final outputs.
Sir, how will you know that the XOR and XNOR, sir?
This expression is XNOR, right? So XNOR, I hope you know. Okay. We we were taught like the XOR gate is nothing but F is, let's say, A B bar plus A bar B. Similarly, XNOR is A B plus A bar B bar. So these are also written in that form. So I can also write this as A XNOR B. This is A XOR B. We calculate this using a K-map also. I hope you can do that. Shall we move ahead?
Okay, sir.
Okay. Two inputs. Okay. Let's skip this. Will take some time. So quickly tell me the answer of this. The number of select lines for 32 to 1 multiplexer is?
5.
Yeah, it's 5. So not solving it, it's very easy. Okay, it says identify the following circuit.
2 to 4 decoder.
1:4 demultiplex, sir.
So this particular circuit has a single input. Sorry. This and it has 2 select lines and 4 outputs. So it is a 1 cross 4 DMUX. It is option B. Okay, let's skip this also. I don't. Okay, let me know the answer to this. A 4 cross 1 multiplexer is shown in the figure below. The output Z is what? Okay, please be aware, here it is I0 and here it is I3. That means this will be A bar B bar and this will be AB. May zoom this. If you try to write Z, it is A bar B bar C plus A bar B C plus A B bar C bar plus A B C bar. which is summation 001, 011 is 3, this is 1004, 6. Okay.
सर ये कैसे हुआ एक बार बता दीजिए.
Okay. So as I said, that's I naught is A bar B bar, and we are multiplying this with C. This is C. This is C bar. This is C bar. So as we were doing before, so this is 1, 0, 1, and this is 2. So the final Z is nothing but A bar B bar C, which is this particular term. Then plus this term, which is A bar B C. This is which is this. Then A B bar C bar, which is this, and A B C bar, which is this.
Sir, it
Yes.
is confusing. From top to bottom they given, sir.
Yeah, yeah, yeah.
So bottom
So
to top they
yeah,
given,
yeah.
sir.
Instead of top to bottom, they've given it from bottom to top. Yeah. Okay, so we need to simplify it. So let's try maybe taking what can we take common? Okay, so we need to make it either B XOR C or A XOR C. So let's say if I take A common from these two. Okay, let me check. Okay. Anyone with any answer? The simplification of this is causing A XOR C. Okay. Okay, let me check. So let's take maybe can I take common? Let's okay. So if I let's say take B common from this, I'm not sure. My pen is not working. Irritating actually. Okay. A bar C plus A C bar plus now I can take B bar common. It will again be A bar C plus A C bar, and it will be A bar C plus A C bar times B plus B bar, which is nothing but 1. So the final answer would be A XOR C, which is option D.
Sir,
Yes.
sir, A should have no, sir, dash on top.
What?
For it being XOR,
Uh,
A bar C plus. Okay, XOR is correct.
okay. So let's move ahead. Okay, you need to find this output. Take 2-3 minutes and let me know the answers in the chat box. Okay, I've got very mixed answers. Some are saying 0, some are. I'm getting very mixed answers. Some are saying X, some are saying 0, some are saying A. Okay, let's see. So the select line of the first multiplexer is 1. So what is the output of the first multiplexer? Can anyone tell? What will be the output here?
1.
Yeah, so since the select line is 1, so this output will be 1 here. Now the second multiplexer, the select line is 0. So what will be the output of the second multiplexer?
0.
So this will be connected here, so the output will be X here. Now for the third multiplexer, since the select line is 1, what is the output? So this will be connected to this, so the output will be X.
1.
I hope it is clear. I mean, this is what we have done. So this was a very easy question, and it's a good question to demonstrate how the select lines are getting chosen. So let's do this. How many minimum multiplexer is required to implement a function this? Apart from mux, only inverters are allowed. So this is a good question. Try it out and let me know the answers in the chat box. Again, I think I'm getting mixed answers. So some are saying A and some are saying B. So it says the inverters are allowed. So you need to make this expression, right? So what is this expression if I try to write in terms of, let's say min terms, it's already 0, 1, 2, 5. So 0 it's A bar, B bar, C bar. 1 is, yeah, 0, 0, 1. 2 it's 0, 1, 0. Then it's 5, which is 1, 0, 1, right? So let's say it says only inverters are allowed. So let me take a 4 cross 1 then, because no extra logic function is allowed. So let's say this is AB. So this will be A bar B bar, right? And A bar B bar contains both C and C bar. So if I make 1 here, the second is A bar B, which is nothing. So I'll like 0 here. Did I write correctly? 0, 1, 0. A bar B. Okay, bar B, it's there. Sorry, right. I need the input as C bar. So since the NOT gate is available, so C bar I can take as an input. The third is A bar B. My bad. A B bar, which is C. The final it's AB, so there is no term of AB, so I can take 0. So this final output will be this only. So since only inverters are allowed, so we cannot make it using 2 cross 1, and 6 cross 1 will not be the minimum number, and it is not even allowed. So option B is the correct answer. Without using, can we get that? Yeah, so full adder and half adder are not universal circuits. So multiplexer is a universal circuit. You can implement anything using a multiplexer. Like you can implement a half adder using a multiplexer, something like that. So yeah, I hope you can understand that. Okay, let's move forward. It says the Boolean function is implemented using 2 input multiplexers. What is the output F? So again, take maybe 2-3 minutes and let me know the answers in the chat box. Okay, all of you are saying A only. So let's see. So it's B, so it will be B bar here. It will be B here. Okay. So since this is connected to this, so here it is E. So E is nothing but B bar C plus B C bar. Again, the pen is giving some problem. Okay, let me write here. Yeah, I'm doing it. I'm doing it. Give me a second. So the output of the first multiplexer is P bar C plus B C bar, which is basically E. That is what I'm saying, because it says E here and it is connected to the output. Right? And the final output is nothing but 0 into E bar plus 1 into E. Oh, not 1, but A into E. So the final output function is A into E, which is A times P bar C plus B C bar. And if we can expand that, because the options are like that, so it will be A B bar C plus A B C bar. Is there any option like that? Yeah, option A is the correct answer. Is it clear to everyone? Okay, let's move ahead. Okay, it says find the number of 2 cross 1 mux required to implement 16 cross 1 mux. I've got mixed answer again, A and C. You need to think that you have single output and 16 inputs. Maybe take 2-3 minutes and write your answers in the chat box. Think more and then write. So those who are saying C, I'm giving you a hint. So for example, let's say we have taken 5 multiplexers. So 5 multiplexer with can only have maximum 10 inputs, right? How can you say that 5 multiplexer can make 16 cross 1 mux? So this is the hint. Maybe take 2 minutes more and let me know the answers in the chat box. Okay, so to do that, you always do a formulation. So start with a more number of mux and start dividing by 2 and then just add. So this is 8, take 8 here by 2. So this is 4, take 4 here by 2, take 2 by 2, that is 1. So the final answer would be the sum of these, which is 15. And why I'm doing it like that, let me explain that also. So at the first stage, as I said, we have 8 mux. So if I make 8 boxes like that, let's say these are 8. So 8 boxes can only give me 16 inputs, right? But these again will have single inputs. And finally, what do you want? You want a single output. So again, you need to give 4 mux in the second stage to feed those, basically to feed those 8 outputs. Now these will have 4, right? So again, you need to give 2 more to have, let's say, 2 outputs. So again, this will have 2, and then finally, yeah, you can say this. So this will be 8 plus 4 plus 2 plus 1, that is 15. Is it clear to everyone? Option A is the correct answer. So let me ask you quickly. Let's say I'm asking how many 4 cross 1 mux are required to make a 32 cross 1 mux. Quickly let me know the answer. Okay, I've got 13, so let's do that. So it's 32 by 4, which is 8. So it's 8 by 4, which is 2, and it's 2 by 4. So 2 of the inputs of 4 were required, so it will be plus 1. So it's 11. Why did you say 15? Okay, some are saying 13, not 15. Did I do something wrong? No. Is it clear how it is 11? Everyone, is it clear? Oh, let's move ahead then. So it says consider a 2-bit multiplexer shown in the figure for output to be XOR of C and D. The inputs, the values of for A0, A1, A2, A3 will be.
Zero one one zero, sir.
Okay, let's check it out. So what do you want is you want the XOR of C and D. So this is C bar D bar, this is C bar D, this is C D bar, this is C D. So you want these two. So it will be 0, 1, 1, 0, right? Which is which option? C. No, this is a circuit diagram of 4 cross 1 mux. Okay, let's move ahead. Now the question says the logical function realized by the circuit shown below is what? I'm getting very quick answers, which is A. So since this is Q, so this will be Q bar, this is Q. So Y will be Q bar times 0. So with my pen. So Y will be, let me write here, Q bar times 0 plus P times Q, which is PQ only, which is option A. Let's move to the next problem. So it says the logic function implemented by the circuit is what? So what all of you are saying D, I think. So since this is 0, this will be 1, this will be 0, right? So this will be 1, 1, 0. So F is nothing but P bar Q plus PQ bar, which is XOR. So yeah, D is the correct answer. Again, so it says a boolean for the expression for the output of the multiplexer is what? So all of you are saying B. Okay, so it's basically P bar Q bar, this P bar Q, PQ bar, PQ. So if I write in terms of min terms, it's 0, 0, 1, which is 1. It's 0, 1, 0, which is 2. No, 0, 1, 0, 1, 0, it's 2. 1, 0, 0, it's 4, and 7. Yeah. So it's XOR. So it's PQ or XOR, which is option B. B is the correct answer. Okay, some of I've got. Please solve assignment question number 5. So question number 5, I already told you it's a 1x1 demultiplexer. I think somewhere I've told. Where did I tell? Somewhere I did tell, I think. I could not find it now. Yeah, this is question 5, I think, of the assignment. Yeah. Is it fine? Yeah, I think these are all the questions that I have. So is there any doubt in the last question that we have done?
No, sir.
Okay, so I think these are all the questions that that were there for this week. So maybe we can meet now next week at the same time. So thank you everyone for joining. Let me stop the recording.
Sir.
Okay, bye, sir.
Sir, doubt, sir.